Hello, everyone, and welcome to the Varsity Tutors StarCourse series. I'm here with the crew at the Omaha Children's Museum, and today we're going to be learning some swashbuckling science with our friend No Beard the Pirate. And while No Beard will be the captain on today's journey, we'll be looking for lots of input from our crew, all of you. So throughout today's adventure, ask and answer questions as we go, and you can use that chat panel on the right-hand side of your screen to do so. Now, if we don't get to those questions right away, not to worry, we're going to have some time for some pirate-themed Q&A toward the end of today's lesson. And you'll also want to make sure that you take a peek at the Pirates Compass project page, which is linked on today's class webpage, so you can participate along with today's activity. All right, everyone, are you ready to set sail on today's adventure? Because I think it is time for No Beard the Pirate to take the helm and get us started.
Ahoy there, mateys! As she said, I am Captain No Beard the Pirate, the infamous pirate, if you will, and I am super excited to be going on an adventure with you. And I think the perfect adventure is a treasure hunt, yo-ho! So, I have a slight hiccup in me plan, me hearties. My first mate Mike here is a little under the weather, you might say. Hi, Mikey. You home? All right, well, let's see. Some of you might say he seems a little old to be set in the seas, but I assure you, he's the best mate that ever did live. So, in order to perk Mike up a little bit, we're gonna use a little dry ice. Have you heard of dry ice, would you say? It's not like normal ice. Normal ice, when you put it out in the heat, in the hot sun, in the sea, it starts to melt and turn into, what does it turn into? Oh, that's right, water. But this ice, dry ice, is a little different. It is made out of a gas called carbon dioxide. And when it starts being put out into the heat of the sun on the vast seas, it starts turning straight into a gas, a process we call sublimation. It's a fancy pirate word. Sublimation. So I'm gonna pull some out, sweethearties. But first, I need my special pirate gloves. Dry ice, you see, is 110 degrees below zero. That's enough to freeze your frigates or to tip your Titanic, as it were. Give me one moment here, me hearties. Get out the special dry ice. Here it is. I'm gonna put it right inside here. Have a little bar, would you say? We're gonna pour a little warm water into it. Let's see what happens, me hearties. Oh. Mike? Are you there, my G? There you are, you home, do you see it? Look, it's burning up already. See all the white smoke coming out? Process of sublimation. The dry ice is turning straight back into a gas. Well then, Mike, I'm gonna put you right over here for our adventure. Heat for what every pirate needs. Oh, it's perfect. Wonderful. Let's move on, me mateys. Now, we are about ready to set sail on the mighty seas, but what is that, Mike? What? What's over there? Oh no, it's an enemy pirate ship coming to get us. We need to man the hatches. Heave-ho! Start to get the cannon ready. Oh, my cannon. We should probably set up a cannon. Heard me, mates. So here, we need a couple things in order to get this cannon going. We need some fuel. which I have here, is isopropyl alcohol. We need some air, which is where? Where can we find our air, our oxygen? That's right, me hearties, all around us. And then last but not least, we need our fire, which is gonna help ignite and blast off. Thank you, me hearty. Perfect. I'm gonna use this for our cannon today. Perfect. Yo. I'm gonna stuff this is our cannonball. I'm gonna put it right here. Perfect. So I'm going to put our alcohol inside me tube. Open it up. Here I'm gonna put 3 of these packets in here. 1, 2, and 3. Perfect. So happy fuel. The next part we talked about was the oxygen. So I'm gonna just flip with this, me hearties. Let's say what, about 7 more times? Will you count with me? 1, 2, 3, 4. Sometimes pirates forget how to count. What was that? 4, 5, 6, and 7, me hearties. Giving it a little time to evaporate. Now I got my oxygen, I've got my fuel, and the last thing I need is my ignition, which is my fire. I put a little more alcohol to lead the flame down in there. And this is gonna make what we call a combustion reaction. So make it go boom. I'm gonna put on me pirate safety glasses. This is how a lot of pirates lose their eye. And 3, 2, 1. Maybe need a little more alcohol in there. We're gonna try it again, pirates. Sometimes experiments don't work exactly how we plan them to, but that's all right. It's all part of learning. And pirates have to learn a lot in order to go through the 7 seas. Let's try it again. We're gonna stir it a couple more times. Just do a couple more times just for good luck. One last time. Perfect. 3, 2, 1. Did you see it? Belching belugas, it flew right out of there. Perfect, we got our combustion reaction. Whew. Yikes, see you later, you belligerent idiots. Well, let's see. What was that, Mike? Mike, you. What'd you say, Fred? What's over there? No, not over there. Up in the clouds. Oh, I see it. It's a typhoon. Oh, no, hearties. A typhoon. If you've never heard of a typhoon, it can be quite dangerous. It forms in the ocean. So, we're going to do a demonstration here. First, I need some water. Pour it in my glass. I think we should eventually add some food coloring. What I'm gonna do first here, my mates, is I'm gonna put some wind in my jar. Yeah, I'm gonna do that by putting the spoon in here and stirring it super quickly. There we go. It's nice and windy. Yeah. Now I'm gonna add some food coloring, and you're gonna be able to see the swirls in there. Ready? Here we go. So you can see all the way down there. There's a little bit. You can see it's getting a little darker in the center. And it's lighter out on the edges. That's how a typhoon works. Just like a real typhoon, the outer sides are weaker, but the dark part of the center is super strong. The strongest winds can reach more than 200 miles per hour. That's faster than a tornado, me hearties. Yes, yeah. Let's get some clouds on top of it. Whoa. You wasn't kidding me, what a mess. There we are. Whew. Can you imagine that up on the ocean seas? It's pretty crazy. All right. Now, what's that white over there? Yo-ho, me argies, we've spotted land at last. Now, in order for a ship to make land events, we need to put something into the waters. What do we put in the waters in order to make our ship stay where it is? That's right, me hearties. It's an anchor, and I've got our anchor right here. Ready? Say with me, we're gonna say heave ho. Ready? 1, 2, 3, heave ho! It just ain't floating. I wonder why. I mean, it's made out of, I've got this aluminum foil here, and it just, wait a minute. If something's floating on top of the water, that means it's less dense than the water. Density is how thick something is, and it can either be less dense, which means it'll float on top, or more dense, which means it'll sink to the bottom. Right now, my aluminum anchor is floating on top. It's less dense, and we need it to be more dense. So I know what we can do. Pirate hammer. I'm gonna squish this up, hearties, and I'm gonna hammer it out. Woo! Make it a big splashy mess. Just how we pirates like it. Woo! And we're gonna make it smaller. It's not gonna look much like an anchor anymore, but that's all right. It's kind of like a cannonball. Perfect. All right. One last time, my hearties. Perfect. I've gone as far as I can, trying to squeeze all of the air pockets out of my anchor. Now let's see. We're gonna heave ho again on the count of 3. 1, 2, 3. Heave ho! You did it, me hearties. It sunk all the way to the bottom. Ooh. Perfect. We squished all the air pockets out, so now it became more dense than the water, even denser. Perfect. Now that we are on land, we are gonna go ahead and venture our way up through the beaches. What's that I hear? Oh my, I think that's my friend, Crocodile Kyle! It's alright, he's actually really nice. Sometimes he and I have tea parties when nobody's looking. Here you are, Kyle. Perfect. Now, Kyle, my friend, is a crocodile. And you can see here, woo, look at all those sharp, pokey teeth. sharp there. Now, the strength of a crocodile clamping his jaw shut is called a bite force. That crocodile have the strongest bite force as any living animal. What was that? Oh, you're wondering about how much bite force you have? Well, not very much. Probably just enough to eat your fish sticks or chew up your seaweed. Your bite force is about 150 psi. PSI stands for pounds per square inch. Whereas a crocodile here's bite force is over 1,300 psi. Whew, that's a lot. You know what? I think we should do something to demonstrate. I have here a blank. An X marks the spot we write. Now we're gonna say that this chicken is equal to your bite force. I'm gonna drop it on my board here. We're gonna see what happens. Ready? 3, 2, 1. Well, that didn't do very much, did it? I guess our bite force isn't that strong. Now let's see what we can use for my big, strong crocodile's bite force. I have here. Mike, was that Mike? Oh, stop your belly aching. When was the last time you used this? That's what I thought. I have here the beautiful treasure bowling ball. It weighs about 14 pounds, and we shall see what happens to the board when I drop this on it. Ready? 3, 2, 1. Jumping jellyfish! Did you see that? Blank. It broke right through me blank. That is a strong bite force. I would not want something with that strong of a bite biting down on me. No, thank you, sir. Whew. Good thing I don't let Crocodile Kyle on me ship. Yo ho, me mateys. Well, do you hear that? Oh. It's the beautiful, melodious song of a mermaid. Oh, calling us back to sea. Let's pretend to be mermaids. We'll do some mermaid bubbles and sing beautifully with the mermaid. Yo ho yo, a virus like mommy. We're all of our mummies and daddies. The pirate like no offense, Mike. Gotta work on those harmonies, sir. Goodness, those off. So let's make some mermaid bubbles. Now, what shape is a bubble, me hearties? A circle, aye, that's true, but if I make a bubble, it's not really a circle. It's a three-dimensional object, so we call that a sphere. So, what do you think will happen if I try to make a bubble into something that's not a sphere, like a star? You think it might become star-shaped? Oh, some of you think it might still be a sphere? Good guesses. Let's try it and see. Ready? Well, would you look at that? Belching belugas! They're still just spheres. So no matter what shape we use, they're all spheres. And why is that, me mateys? I'll tell you. everything needs something to keep its shape called a skeleton. Otherwise, the air all presses in on it and makes it all look like a sphere. So I have something here. It's kind of like a skeleton. What shape would you say this is? Good guesses. Not quite a square. It has a three-dimensional aspect to it. Oh, that's right, me ladies, it's a cube. So, if I dip my skeleton in the bubble juice here. Oh, you see how it's kind of coming in on the middle? I'm gonna take a straw and I'm gonna poke it in the bubble juice to see if we can make it a little different. Yo! I dip my straw into the bubble juice as well. You see? I have made a cube-shaped square. We'll try it again, shall we? Dip it in my skeleton. Dip my straw in so it doesn't pop it. There, the very picture of mermaid beauty. Now, because it has a skeleton, it is able to form a sphere. It's able to form a cube, rather. Now, if I let it go of the skeleton, it turns back into a sphere. Lovely. Remind me later, Kyle, to put this on you. Give me a skeleton, my lad. Perfect. Oh, now, we've made it through the enemy pirate ships, through the typhoon. We made it, hoisted our anchor down, made it onto shore, past Kyle the crocodile, made our mermaid bubbles, and now, alas, me mateys, look what I spy! We have found our treasure! So beautiful! I've never seen so much treasure in my whole life. It's so beautiful. It's the most beautiful treasure in the whole world. Look at this. Oh, yo. Look at that there. Might be just real gold. Hold on. We must test our treasure. There are so many times when pirates try to fool you. And then they paint other metals. And it's not real treasure. And then you go home to your mommy really sad. So we're gonna test to make sure that this is the real thing. All right, let's see here. Now, here is copper. And we're gonna see to show you how to prove that gold is not copper. Now, copper, it conducts electricity. So I have here to show you what I mean by conducting electricity. I have a circuit. Now, a circuit sounds kind of like a circle, which is why we have to connect these points to make a circle with our wires. Connect those. And I'm going to connect these. And look, our wee little lantern is lighting up. See our wee little lantern lighting up there. Now, what happens if I take it off? Our wee lantern isn't lighting up anymore. But I have some copper. If I hook the copper up, what do you think will happen, Marcus? Oh, you think it'll blow up? It'll shoot a cannonball after you. Hooked it up to the copper. Oh, and look at that! My copper penny has connected a circuit and has made my wee little lantern light up. Is that fantastic? Now, real gold doesn't do that, doesn't react. So we know that this penny, even if I painted it in color gold, it's not real gold. What else have I have here? Ooh, I have a nickel spoon. Now, real gold. If I go over it with a magnet, it won't do anything. But nickel is magnetic. So let's see what happens. Shiver me timbers. It's not real gold either. All right. Now I also have here aluminum foil. Now, do you remember what we learned about our anchor? Whether it was less dense or more dense than the water. In case you forgot, we're gonna do it again, hearties. Now pour the little aluminum flakes up on top here. It's floating on the top. Now, does that mean it is more dense? Or less dense? Can you see it? See the little metal flakes? That's right. The aluminum foil is less dense than the water. So it's not real gold either. Let's see what happens. I put suppose the gold into it. Oh, look at me, it's so beautiful. Do you see the sparkling gold at the bottom? It is more dense. It is denser than the water. Then the aluminum foil flakes on top. Oh, it's so beautiful. I never thought I'd find real gold. Mike, there's a little fix up, would you let? Well, me hearties, this has been quite the journey. Now I feel like we have one last important task for you to do before you go. In order to be real pirates, you need to learn how to make a compass. So we're gonna do this one together. If you have the tools at home, you can go ahead and gather them together. We'll do it all together. If you don't have them yet, that's all right, don't worry, my lads. You can pause this video, go and collect all your items, and then come back to it, and we can do it together then. Perfect. So I have here what you're gonna need is a clear plastic cup. Put my gold to card. You're gonna need a cork. You're gonna need a sewing needle. Careful, these are sharp. You're gonna need a permanent marker and a pair of scissors. On top of all that, you're gonna need a refrigerator magnet. Got all your supplies? Perfect, let's get started. First step is to take your wee needle, your wee mini sword. You're gonna take the magnet, you're gonna rub it, not back and forth, just one way on the needle, just like you're sharpening. You're sharpening your sword for a nice cruise. You might run into pirates. We'll do it about 25 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Wonderful. We're gonna set our mini sword aside. Next, we're gonna grab our cork and our scissors, and we're gonna cut it. You might need an adult's help with this one. Oh, yay! Whoa! Show me timbers. Right? I just need this little bit, anyways. All right, very gently now. Might need some help with your adult as well. Take your mini sword. And you're gonna stick it through the middle of your cart. All the way through. Sometimes you might need to fix it. Beautiful. Wonderful. Alright. Now, our next step is we're gonna put a little bit of water in our cup here. It's always great when you don't have to drink seawater. Alright. Now, we're gonna pick up our cart and very gently, I'm gonna put it on the top of the water. Now, I'm gonna show you our lovely compass we made here. This compass, no matter which way I turn it, will always face north. See, as it's slowly rotating back. Yeah, it's going all the way back here. Ready? 1, 2, 3, spin it. And now it's gonna rotate by itself. Did you see it? It's a pretty cool thing. Now it's always facing north, so you know which way it goes. Awesome. Now, how is it that a needle that we rubbed a magnet on will always face north, you ask? Well, that has to do with the Earth. It's a very long story. Basically, the Earth's car is made up of 2 different items. It's made out of crystal and molten iron. Now, as the Earth does this pretty turn spin on its axis, it makes a magnetic field in it. So, magnetic field has 2 centers of force. It has the north, which we call the North Pole, which is where Santa Claus lives. And the other center is the South Pole, you know, where Santa's mother's sister lives, Auntie Claus. Anyways, the magnetic field of the Earth will always face north. So when we magnetize our needle and we put it in, it'll always lead us true north. And just remember, if you're ever going to use it, to rub the magnet on it before you go. I am so proud, all of your work, shipmates. I wonder if you remembered some from today's adventures. So we're going to do a little pirate quiz. And if you win, you get to do a pirate jig. Perfect. So, get ready. Question the first. Which of these metals is magnetic? Copper, nickel, or gold? Which one of these metals is magnetic? Copper, nickel, or gold? If you answered nickel, give yourselves a royal pirate jig, because that is correct. All right, moving on. Question the second. When we hammered the anchor to make it smaller, did we increase the density or decrease the density? Again, when we hammered the aluminum foil to make it smaller, did we increase the density or decrease the density? If you answered increase the density, bravo, you can give your parrot a little biscuit next time you see him. And finally, question the third. If you blow air into a star-shaped wand, what shape will your bubble be? If you blow air into a star-shaped wand, What shape will your bubble be? If you answered sphere, you are correct. If you got all three of those right, congratulations. You could as well be a captain of your very own crew. Congratulations, me hearties. You are a sharp crew, bright as buttons. It's amazing how much we learned on the high seas. Now, it's time for me and Mike to go off into our own adventures, into the great unknown. Farewell, me hearties. Yo-ho!
All right, Captain No Beard, do you have time before you set off on those adventures for just a couple of our curious aspiring pirates questions?
Absolutely.
Wonderful. Well, then at that, the first thing that our students had to ask is we want to know, do pirates in real life need to know science, and how might it help them?
I only got the first part of that question. Do pirates need to know science?
Pirates need to know science. What sorts of ways can science help them?
Oh, pirates need all sorts of science. We need to know about weather changes, how to read the clouds, how different temperatures on the sea and in the air make storms, and how to navigate those. We have to know about the stars and how to navigate. It's dark. We can't see anything. So we have to be able to track the stars. We have to know how to read maps, how to look at them and know our directions, go north, south, east, west. We have to know how to use compasses or to make our own. And there is so much we have to know about the deep blue sea.
Wonderful. Now, you mentioned a couple of things around weather and the stars and the deep blue. So, are pirates the only people who can benefit from knowing about science, or does anybody else maybe study those sorts of things?
Oh, everyone should study those things. Politicians should study the seas. Children should study the seas. Sharks should study the seas. Pretty much any person in the whole wide world should know about science.
All right, that is awesome. I'll be the first attendee if you decide to host any shark classes where sharks are the participants. We'll be sure to let them know about the next one. Now, we also have questions around some of our experiments. So could you run us through of the experiments that we did today? Which one of these are safe for our pirates at home to do, and which ones should they probably steer clear from, especially if they don't have a very special pirate science studio?
Absolutely. Probably one of my favorite ones to do at home is taking the aluminum foil, throwing it in the water to see if it floats, and then squishing it up as tight as you can to see if you can make it sink. That's a great one. You can also see if something's magnetic. You can see if it will float again. You can also do the compass that we did together, which is a perfect step-by-step instruction on how to do it at home. Those are probably the best ones to do in our case. Oh, and the bubbles. Oh, I love bubbles. You can do bubbles at home too.
All right. Now, speaking of bubbles, we thought that bubble skeleton that we made out of that cube was pretty cool. So we had some students who were wondering, can you make a bubble skeleton out of any other shapes?
I'm sorry, Harty. I've lost my hearing in one ear from the cannon. Can you repeat that?
That's all right. Can you make any skeletons for your bubbles out of other shapes?
Ooh, that's a great question. I'm not really sure. That's something you could try at home, probably. You could try a pyramid. Or maybe, we've already done the cube, but try a pyramid at home and then see if you dip it in and then get your straw. And the key is to dip your straw in the bubble juice and then stick it in the middle. Maybe it could work. That's a great experiment for you to try, and let me know what you find out about.
All right, absolutely will do. Now, we know that you have lots of very pirate-specific expertise. Is there anybody at the Omaha Children's Museum who has any other sort of expertise when it comes to science that we should know about?
Oh, that's a great question. We've got Dr. Frankenstein would probably know. We got lots of scientists here who do science shows here. We have other teachers who come and help us learn our experiments. We have some experts in bubbles that know how to blow bubbles and sometimes light them on fire. That's pretty exciting. We have all sorts of visitors who come and teach us about science here.
Wow, that is amazing. I didn't know that the field of bubble science was a thing, but there you go. Those aspiring scientists who are particularly interested in bubbles, that's a direction that you could take. Now, we talked about how important it is for our pirates to understand science. Are there any other things that pirates need to make sure that they're paying extra close attention to in school to make sure that in their adventuring and exploring, they're prepared with all the tools they need?
Every aspect of science is very important, especially for a pirate science. You have to know your history very well. Also, safety is a crucial part to being a pirate, so make sure you listen for that. Men need to know chemistry, because you look at your chemicals like alcohol and other things. That's very important, especially when you're lighting things on fire. You have to know your chemistry. Lots of reading. Lots of reading, because you have to know the manners of all the different countries you go to. Asking questions. Asking questions is a great way of learning. Ask everyone lots of questions, and you learn so much you don't know. Probably my top tips.
Awesome. That is great. I didn't know that pirates were known for their manners, but perhaps we are taking new strides in the future of exploring and piracy. All right, well, it's getting to be about that time, but we did have some students who are very excited to know what we've got coming up next. So I will go ahead and mention that everyone should stay tuned, because on November 16th, the Omaha Children's Museum will be rejoining us, and we'll be talking a little bit about some great minds other than the great mind of Captain No Beard, of course. So in the meantime, thank you so much, everyone, for joining us. Thank you, Captain No Beard, and the entire team at the museum. We hope to see everybody back in another Varsity Tutors StarCourse soon. And in the meantime, if you learned something new today, feel free to tag us both and let us know what you learned. Thanks, everyone.